Welcome to the final module of the course. In this module we'll learn all about problem solving, how to follow a structured methodology that you can use throughout your organisation to get breakthrough results again and again. This is one of the longer modules, so please feel free to have a break or jot down notes and pause the videos in between. So let's go.
The secret to many companies' success is Kaizen, continuous improvement. In order to continuously improve, you need to be capable of solving problems in a fast, effective, and consistent way. Throughout this module, we'll teach an approach we call CPS, Collaborative Problem Solving, an extension to A3 problem solving created by Toyota. A point to note is that you may hear people referring to Kaizen events. These are where you use a problem-solving approach like CPS within a workshop style with a dedicated team. Problems are inevitable within any organisation. It is the nature in which a company solves problems that dictates its culture and its success. Every problem identified is a chance to increase your competitive advantage and maximise the potential of your organisation. Problems should be viewed as golden opportunities to improve. Any company that shies away from problems, brushes them under the carpet, or ignores them clearly has a long way to go in their lean journey, starting with taking accountability that problem solving is everyone's responsibility. The approach trained in this module has been used by top management to solve multi-million-pound problems. It has also been used by frontline operators to solve much less impactful but still important problems. Anyone can use this approach, you just need to strictly follow the methodology. The approach taught throughout this module will enable you to solve problems using a structured approach that targets the root causes of the problems, preventing them from reoccurring. As with many lean tools, the involvement of people at the front line is essential, hence the word collaborative in collaborative problem solving. The truth is that top management and leaders are typically only aware of 5% of a company's problems. Just like an iceberg, in order to attack the hidden problems, you need to involve the frontline operators. Problems vary in nature and complexity. In order to effectively solve problems, you should select the appropriate problem-solving tool, a tool that is adequate but not overly complex and time-consuming for the specific problem. Don't be put off by the apparent complexity of this graph. It just shows how different tools should be selected based on a problem's difficulty. There is no formula or exact way of selecting the problem-solving tool, and it often relies on experience and logic. For very basic problems, a just-do-it approach can be taken, and a specific tool isn't required. There is no need to use complex tools to solve very simple problems. Often OPLs, one-point lessons, or SOPs, standard operating procedures, can be used to prevent problems from reoccurring. A PDSA approach, plan, do, study, act approach can be taken. You first plan what to do, you then carry out the plan, you follow up with feedback loop where you study the result to determine the impact of the action, and then you finally act, either concluding the solution or experimenting with something else as the desired result has not yet been achieved. This PDSA, or sometimes known as PDCA, with the C meaning check instead of study, this is known as the Deming cycle and is the basis for scientific problem solving. Making a hypothesis, testing an action, receiving feedback, and acting on that feedback. This problem-solving approach can solve roughly 90% of all problems, the relatively simple problems. A very basic example of this four-step PDSA approach could be: I have a problem where the fire that I'm trying to light keeps going out. I know from experience that fire requires heat, fuel and oxygen to survive, so I devise a plan. My plan is to try a different fuel in the form of a different type of wood. I then move on to the do stage, where I change the type of wood and try igniting it. I then move on to the study stage, where I observe for any changes and see that the fire starts to go out. Finally, I move to the act stage, where I decide whether my result has been achieved or not. As in this case, it hasn't been achieved, so I return back to the plan stage to plan a new experiment. I believe the wood is not getting enough oxygen, so plan to raise the wood so air can get underneath it. Moving on to do, I raise the wood and light the fire. Having done this, I then move to the study stage, where I observe and measure the impact. As the fire is staying lit and the flames getting larger, I can now move to the act stage. As I have achieved my result, I can now close the problem as it has been solved. This iterative loop of plan, do, study, act can solve the majority of problems, especially simple problems. The limitation of this approach becomes clear when problems grow in complexity. A more robust and detailed approach is required that uses the collective knowledge of a team. This will be the primary focus for this module. The approach is called CPS, or Collaborative Problem Solving. If you are familiar with A3 problem solving, then you'll see lots of similarities between that and CPS. If you aren't aware of A3 problem solving, then do not worry. CPS encompasses A3 problem solving, and you'll be an expert by the end of this module. Just like A3 problem solving, collaborative problem solving enables complex problems to be solved and communicated within a single sheet of A3 paper. The importance in this is that anyone should be able to pick up the A3 and read it like a story, from start, describing the problem, to end, sharing the lessons learnt, in the space of 5 minutes. Emphasised in the visual management module, A3s maximise the benefits of visual learning using graphs, diagrams and colours to help convey information wherever possible. This is what a collaborative problem-solving template will look like, divided into 9 manageable steps and 3 main stages: planning, creating solutions and tracking benefits. I'll first explain how each step should be carried out. We'll then look at a real-world example and provide you with some tips. The first stage is defining the problem. A problem arises when there is a difference between expectation and reality. The expectation could be that 100% of products are delivered on time in full, and the reality is that 82% is achieved. The expectation could be that 100% of products reaching the customer are non-defective. If the reality is that 35% are defective, then that is the problem. Problems include deviations to a standard, customer needs not being met, or a change in conditions. The first part of step 1, defining the problem, is creating a succinct, summarised statement that describes the problem. Poor problem statements are often general, whereas a good statement is specific, customer-related, and measurable. Once the problem statement has been written, it's time to make clear why it is a real problem. Who is affected by the problem? What is the monetary impact? How is the customer affected? In other words, why is this problem the problem that we should be focusing on? Einstein once said, "If I were given 1 hour to save the planet, I would spend 59 minutes defining the problem and 1 minute resolving it." In more cases than not, people jump into solving a problem without understanding why the problem has been selected. Spending time to properly define the problem helps in finding the solution. When completing step 1, it's often important to ask questions like, what is in scope and what is out of scope of our team? There is no point discussing a problem if you don't have the people in the room that can actually solve it. Once step 1 has been achieved, it's now time to move on to step 2. This should be answered with data, graphs, diagrams and charts, not with words. Step 2 is all about investigation, asking the right questions to find out more about the problem. Identifying the current condition is one of the most time-consuming and data-driven aspects of the problem-solving approach. It is all about viewing the problem in data, understanding where the problem occurs, when, which, who, how and how much, often abbreviated to 5W2H. By breaking a big problem into smaller problems, it can be solved much easier and with more accuracy. The 5W2H approach will be explained more when we actually go through an example. The key thing is to make sure that you answer these questions with graphs. Graphs and diagrams provide simple visualization to represent often very complex and unclear data, identifying a trend, relationship, or behavior of different variables. Something that may appear random or insignificant can be proven differently when represented on a graph. By asking these 5W2H questions, we ensure that the right questions are being asked. Imagine you're an investigator. You want to know where the crimes have been committed, who was involved, at what time, what was the nature of the crime, etc. Once you have gathered all the information, you can then start to look for patterns and draw data-driven solutions from it. For example, if you're trying to look at an opportunity to save money on your electricity bill, once you have clearly stated the problem, you arrive at step 2 and begin collating the data. You start by looking at when from the 5W2H and find that the electricity bill is higher in the winter than the summer. This is expected. However, when you look more granularly, you find that every Wednesday you have a big spike in power usage. Looking deeper, you find that it is always between 6 p.m. and 7 p.m. Just like an investigation, you want to understand who may know more about this, so you speak with the other members of the house and ask where everyone is during this time on Wednesday. One person says that's the time they arrive home from football training each week, and they have a bath. As you dig deeper and ask more questions, you understand that they are currently boiling the kettle 30 times in a row to fill the bath, as they believe the boiler is broken. And there you have it, you have found your answer. I know this is a silly example, but when not asking the right questions or using data, many companies go round and round with similar issues, trying to solve the problem with little success. A Pareto graph is a highly effective graph for step 2 of problem solving. Named after an Italian man who observed that 80% of the wealth in Italy belonged to about 20% of the population, the Pareto graph allows you to see the wood through the trees, with an understanding of what is significant and what is trivial. On the left y-axis, we have frequency, and on the right side of the y-axis, and the light blue line on the graph, we have the cumulative frequency. Along the x-axis, we have all the contribution factors ordered from big to small. To create a Pareto graph, we should find the 80% point on the cumulative frequency line, the light blue line, and draw it vertically down until it crosses the x-axis. Now we know all the factors on the left of this point contribute to 80% of the problem. This graph is a favourite among consultants and a great way to dissect a problem down. In this example, by creating a Pareto graph, you can see that by focusing on the top 6 reasons for customer complaints, you'll be impacting over 80% of all the complaints. Therefore, focus on the many other factors is not as worthwhile as those 6. Again, we'll look at this in more detail when we go through the real-world example afterwards. Once we have understood the current state in step 2, we can move on to step 3, which is setting a smart target. Setting a target can often feel unimportant, with the attitude that if you work as hard as you can anyway, then that is the main objective. However, the act of setting a goal requires commitment, and having commitment means that you are willing to work hard, despite the obstacles in your path, in order to make your dreams a reality. As they say, if you aim for nothing, you'll hit it every time. You probably will have heard of SMART targets before. SMART targets mean they should be specific, i.e. clearly defined, easy to understand. They should be measurable, so they can be measured easily and cost effectively, and monitored through time. They should be actionable, so the team can influence the attained result, and the root causes are understood. They should be relevant, so they're relevant to the business and they support the primary goals of the organisation. And finally, they should be time-bound. In other words, they have a specific time frame and results are expected by a specific date. An example could be reduction of customer complaints. average monthly number of customer complaints reduced from 11 monthly average from 2015 to less than 6 in July 2016. This fulfills all the criteria of a SMART target. Now we have completed step 3, we move on to the solution part of the problem-solving methodology, starting with step 4, finding the root cause of the problem. There are 2 main methods for finding the root cause of a problem: fishbone diagrams and the 5 whys method. The 5 whys method literally means asking the question why 5 or however many times. Repeatedly asking why may be a child's preferred technique for getting the information they need, but is also a remarkably simple and effective tool for root cause analysis. Every team faces roadblocks in their daily work. By using the 5 whys, will help you find the root cause of any problem and protect the process from recurring mistakes and failures. Let's look at an example. A machine has broken down. So why did the machine stop? Well, there was an overload and the fuse blew. Well, why was there an overload? The bearing was not sufficiently lubricated. Why was it not lubricated? Well, the lubrication pump has stopped operating. Why has the pump stopped? The shaft of the pump was worn out and chattering. Why was the shaft worn out? Well, there was no filter attached, and metal scraps were entering the reservoir. And there you have it. You have found the root cause to the problem. Without asking why so many times, you would have missed this root cause and likely implemented a countermeasure, only to find the problem happen and reoccur again a few weeks later. This 5 whys methodology was created by Sakichi Toyoda and is used frequently today within Toyota. The reason it is specifically 5 is just because that was found to be the most common number of whys required to find the root cause. In reality, it could be many more or many less whys. A great example of the 5 whys methodology in action can be seen with the Jefferson Memorial example. The National Park Service executives had a problem. The stone interior of the memorial was deteriorating and showing signs of wear. They considered replacing the stone or even painting over it on a frequent basis, but this solution was just too expensive. They asked why. Why was the stone deteriorating so fast? The maintenance team replied saying, "We use very high-powered jet washers every 2 weeks, which damages the stone." The National Park Services then asked why once more, to find that it was because of bird droppings. Jumping to conclusions and stopping there, the Park Services ordered nets to be put up around the memorial to deter birds from sitting on the memorial. Unfortunately, the birds found ways around these nets, and the nets also created an eyesore for tourists. A 5 whys investigation was launched. Why were there so many birds? Well, because there were a lot of spiders nesting there. Well, why were there a lot of spiders? Because there were even more insects there. Well, why were insects attracted there? Because of a high-powered and constant lighting of the memorial. They had found the root cause, a high level of light on the memorial. Having found this root cause, they quickly implemented a solution. By changing the timings of the lights to be on for 4 hours less each day, i.e. from midnight to 4 a.m, when fewer visitors were present, this resulted in a 90% reduction in insect numbers and eliminated the source of the problem. Not only that, but they also saved on their electricity bill, all thanks to the 5 whys approach. The next method for root cause analysis is my personal favourite, the fishbone, ishikawa, or cause and effect diagram. This fishbone diagram categorises possible causes into distinct categories. The reason fishbone diagrams are so effective is the way in which they're populated. A team of experts in the process, which may be operators on the shop floor, are gathered together and in silence, without communication, are asked for any possible causes for the problem occurring. With help of the 6 categories, it prompts them to think of as many options as possible. Going from person to person, each cause is written down onto a board until they have all been exhausted. Then comes the clever bit, prioritization. Each member ranks which cause they believe has the biggest impact on the problem and which one has the least. Collating everyone's thoughts together and understanding their reasoning means a collective picture is painted using the collaboration of everyone. In 1906, a statistician called Francis Galton made a discovery of what is now known as the wisdom of crowds. He attended a farmer's fair in Plymouth where he was intrigued by the weight guessing contest. The goal was to guess the weight of an ox when it had been butchered and dressed. Roughly 800 people entered the contest and wrote their guesses onto tickets. The person who guessed closest to the butchered weight of an ox won it as a prize. After the contest, Galton took the tickets and ran a statistical analysis on them. He discovered that the average guess of all the entrants was 1,197 pounds. The true weight of the ox was 1,198 pounds. The guess was to 99.9% accuracy of the real weight. This collective estimate was not only better than the actual winner of the contest, but also better than the guesses made by cattle experts at the fair. It just goes to show that collective knowledge is almost always more accurate than a limited number of expert views. That is why the fishbone diagram is so effective when conducted in a way like this. A caveat to this is that it is extremely important that when creating a fishbone diagram, the members of the team are familiar with and understand the problem at hand. Otherwise, hypothetical and inaccurate causes will be identified. The use of data is also highly encouraged here when possible. Otherwise, biased opinions may unintentionally sway the results. Once all the root causes have been found, we can then move on to step 5, designing the actual solution. The key word here is creativity. Remove any preconceptions, space constraints, past experiences, and start with a blank canvas. Why do we do it that way? Why is it in that order? Why can't the information be available beforehand? This questioning mentality is what helps create innovative and powerful solutions here. At the very least, a solution should help detect the problem, and wherever possible, it should prevent it from reoccurring. Henry Ford famously invented the moving production line, having just visited a slaughterhouse and seeing carcasses hung from the ceiling, moving along the production process. There are lessons to be learnt from other industries, and inspiration can be drawn from anywhere. I don't want to diverge too far from problem solving, but biomimicry is the practice of learning from the designs in nature. Treating evolution as the research and development process, nature has developed some incredible solutions to problems that are similar in nature to many human problems. Look at the design of the B-2 bomber compared to a peregrine falcon, or the design inspiration for Velcro. When brainstorming possible solutions, if you are ever unsure on how something works, go to the Gemba. Ask the people that know the process best, and try to find the simplest, most effective solution. Try and avoid thinking of restrictions and think, how can it be done? Once the solutions have been identified, it is now time to prioritise them based on their effort and impact, or their cost and their benefit. This can be done using a matrix. We can now move on to step 6, testing the solutions. This can mean many different things based on the nature of each problem. It may involve creating a mock-up, doing a test run, or testing a new approach in an offline environment. The key thing here is proof of concept. Testing solutions means proving that the solution is practical and planning any other tests that need to be carried out. Once the tests have been completed and the solution has been refined, it's time to implement with the aid of an action plan. The action plan should include a deadline, actions, and the person responsible in order to retain accountability. The project leader should take responsibility to ensure people are up to date and on track with their actions. Once the solutions have been implemented, the next step is to confirm the results. Just like the PDSA cycle mentioned earlier, this is the study part. The plan has been made, the solution implemented, now the results need to be measured, and finally the feedback loop closed. This important stage acts as the feedback to confirm that either what has been implemented has the desired result or not. The fact of the matter is, some problems that you solve are very complicated and involve unknowns. There is nothing wrong with finding out that a solution hasn't had the desired effect. That is what becoming a learning organisation is all about: experimentation and continuously improving towards that lean state. On the other hand, if you confirm results and find that your target has been achieved, then it's time to create standards and ensure that improvements stick. A good analogy is to remember the wheel of improvement in the standards module, where the standard acts as a wedge to keep the improvements. Without standards, improvements can be lost. In terms of confirming results, this is where the SMART target from step 3 comes in. It provides a KPI or multiple KPIs that can be measured and compared against. It is now time to measure the KPI and see whether the desired outcome has been achieved. The final stage of problem solving is identifying other processes or areas that could benefit from similar solutions. The chances are other departments, teams, or processes could benefit from learning about the solution implemented. That is why communicating the improvement organisation-wide can be a very powerful thing to do. Any lessons learnt from the project should be noted, and upon starting the next problem-solving workshop, previous lessons learnt should be referred to. So, now that we have gone through each of the 9 steps involved in collaborative problem solving, let's look at a real-world example. The problem we are trying to solve is that in 2020, our company of 100 people spent 104,800 hours in meetings. This time could have been better spent adding value to our stakeholders. Now that the problem has been defined, we move on to step 2, where we should answer it with data and graphs, not with words. In this case, the problem is further defined with the question, what? What is the problem? Identifying that each employee spends on average 58% of their working time at meetings. Now asking the question, where? Where is the problem? Well, the problem is much bigger in the Birmingham office than the London or Manchester office. Meeting room 4 in the Birmingham office has over double the occupancy of any other office room. Moving on to when, looking at the problem over the space of a year, you can see that there are big spikes in early February, April, and around the end of the year. This information will become useful when looking at the root causes for the problem. By looking at the meeting attendance by department, it can be seen that human resources, administration, and marketing departments account for 78% of the entire problem. This Pareto chart easily separates the trivial many from the vital few. By identifying which type of meetings occur, it can be seen that 30% are training meetings, 25% are conferences, 23% are preparation meetings, while only 16% are normal meetings and 6% are follow-ups. Finally, it's time to quantify the size of the problem using monetary values wherever possible. This problem costs the company £1.856 million per year. Based on the current state that we have now analysed, we can now use what we have learnt to create a SMART target. Since we've found that throughout a large part of the year, 25% average meeting time is achievable, we could then set that as our target throughout the entire year. Our SMART target would then be a reduction in average time spent in meetings from 58% in 2020 to 25% in 2021. Now comes finding the root causes for this problem. Holding a workshop with team members from each department, so from HR, administration, marketing, operations, etc., the root causes for the large amount of time spent on meetings can be identified. By combining a fishbone diagram with a 5 whys approach, the causes for all the problems are identified and can be prioritised. When reviewing the current state data, A member of the administration department says that the two spikes in February and April are because the metric, time spent in meetings, includes travel time, and at that time of the year, 2 week-long conferences are held in Spain. The team member then explains how, out of the 1 week-long conferences, 2 days is spent travelling there and back from the UK. A member of the HR team then explains how a large portion of their time is spent travelling to training meetings that take place twice per week. Other root causes are identified, being the lack of agenda, as well as no one being assigned responsibility to invite people to the meetings. Finally, a member of the Birmingham office explains how the projector in meeting room 4 hasn't been working for a long time, and as other meeting rooms are occupied, they're spending excessive time using a whiteboard instead. The top 5 root causes are marked with a red post-it note and will have actions taken to mitigate them from occurring again. As you can see in this example, all 6 categories, including materials and Mother Nature, haven't been filled in. It's common for some of the categories to not have any root causes associated. Don't worry about filling them up for the sake of it. Moving on to step 5, the team brainstorms solutions for each problem and prioritise them onto a cost-benefit template. They find that the quickest wins include creating agendas for each meeting and assigning the meeting leader to invite new members to the meeting. Together, they decided that instead of a 2-week conference in Spain, the same outcomes could be achieved in a 1-week conference in Oxfordshire, saving 4 days per person associated with travel. Finally, the HR team decided to change to a centralised training team, preventing them from having to travel for 2 days each week. Testing the solution meant the meeting agenda had to be decided for each team. A meeting leader was assigned and the helpline phone number to fix the projector was retrieved. Different venues for the weekly meeting were assessed and one was selected. The people required to form the internal training team were shortlisted. All the preparation and testing has been completed. Now we move on to implementation. The implementation was very simple and involved making the changes and working to the new way. Any outstanding actions or changes required were recorded. We now move on to step 8, confirming the results and creating the standards. The time spent in meetings was monitored and recorded. By the end of September, the average time spent was just 27%, only 2% over the target. The large spikes in February and April had massively been reduced. The project leader or sponsor now needs to work hard over the coming months to aim for the 25% target. At this part of the problem-solving methodology, it is good to regather the team together and discuss the results and close any outstanding actions and points that may need addressing. For example, a member of the team may have feedback of another small improvement that could also be made. Finally, since all the hard work has been completed, the last stage of the problem solving is identifying other processes or areas that could benefit from similar solutions, as well as celebrating the success. For example, similar processes such as onboarding new employees or the corporate's event planning team may be able to apply similar solutions within their own team. And that is typically what a completed collaborative problem-solving A3 will look like. As stated before, it can be picked up and read by anyone, in 1 page and in under 5 minutes, quickly understanding the nature of the problem, all the way through to the solution and the lessons learnt. This particular example has been chosen as it is a typical problem that arises in a lot of companies. However, this structured methodology for problem solving can be used in any circumstances. For example, when using it at an automotive company, aiming to reduce the number of customer complaints, a Pareto chart soon identified that paint faults were the cause of over 80% of all customer complaints. Once reaching the root cause analysis step, a member of the team identified a peculiar trend. Nearly all defects were originated from one of the 6 paint booths, and upon further investigation, only on days when the weather was very cold. The team had discovered that the paint booth, being so close to the exterior wall, was creating a large temperature differential that caused bubbles in the paintwork. As a team, they brainstormed ideas and ended up adding extra insulation to the wall, and problems disappeared, saving the company millions of pounds per year. That is why this template is so useful. You can follow along with it and communicate a problem and how it was solved with such ease and in a repeatable way.
Collaborative problem solving is all about following the strict methodology, the 9 steps that we've outlined. It's all about involving people. Remember, the frontline operators, the shop floor workers, are most aware of problems within your business. And that finalises this course. This last part, problem solving, combines so many aspects that we've learned throughout the course. Making problems visible, the act of going to Gemba, identifying wastes, visual management, people involvement, and many more. So please join us on the last module where we'll be discussing certification and how you can sit the examination and become accredited.